Alright kiddos, here we go. I'm going to tell you right now that you need to buckle up because this video is going to be a long video. It's going to be very involved. It's got lots going on, so buckle up and get ready for the ride. Before we start, two things. Number one, I have posted these notes on Edline so you can pause and go print them off so you can have them to use while we go through here so you don't have to draw and sketch all this. And number two, I want to give a shout out to Aubrey, who has been working really hard to try and make sure that she gets the videos watched and gets her notes taken every single day, even though she is having some serious internet issues at home. She's been doing everything she can, including going to the public library just so she can get her video watched, and her notes are gorgeous. If you want an example of what to do and how to take notes, Aubrey's are fabulous, so take a look. Good job, Aubrey, and so let's kick this off. Parallel and perpendicular lines. We all know what they are. We've all dealt with them before, but now we're just going to talk about the slopes of the lines. The first thing we're asked to do is we're just going to plot these 4 points and connect them and then find their slopes. So let's plot these 4 points first. A is at -4, 1. B is at -2, 1, 2, 3, 4. C is at 4, 0. And D is at 2, -3. And so let's connect all these with our lines so that we have lines connecting each of our points. And hopefully you will see we just made a lovely little rectangle. And hopefully you know that in rectangles, opposite sides are parallel, and adjacent sides, which means sides that are touching side by side, are going to be perpendicular because they intersect at a right angle. So let's find the slopes of each of these lines. The slope of line AB, I can either use my points and do the slope formula, so I can do the change in y over the change in x, or I can just count on my graph. I'm going to count on my graph. So to get from point A to point B, I go up 1, 2, 3, and over 1, 2. So my rise is 3. My run is 2, so my slope is 3 over 2. Now to get from B to C, this line decreases from left to right. So I'm going to go down 1, 2, 3, 4, which is a -4, and over 1, 2, 3, 4, 5, 6. So it becomes -4 over 6. And that will simplify. And it's important that you simplify. This becomes -2 over 3. It is important that you simplify, especially for the purpose of this lesson, or you will not see what I need you to see. Now line CD, from C to D, I go down 1, 2, 3, and to the left 1, 2. Since I went down and left, that's a negative over a negative, which is positive 3 over 2. And then line AD, to get from A to D or from D to A, either one, I went down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So this one's -4 over 6, or -2/3 as well. So there are my slopes. I have 3 over 2, -2/3, 3 over 2, and -2/3. And it's going to be important on the next page. So it asks, what do you notice about the slopes of the following lines? And so we're going to compare them. The slopes of A, B, and CD. Well, if we look here, A, B, and CD, hopefully you notice that they are the same. The slope of AB is the exact same slope as the slope of CD. And if you look at line AB and line CD, hopefully you notice that they are parallel. They are on opposite ends of the rectangle, and they are parallel from each other. So these slopes are the same. Now the next pair is BC and DA. Well, BC and DA are also parallel. They are the top and the bottom of the rectangle, and so their slopes are -2/3 and -2/3. Well, their slopes are also the same. These lines were what we call parallel. This is the symbol for parallel. And then let's look at CD and DA really quick. CD is here. DA is here. Well, they are adjacent sides, which means they meet, and they meet at a right angle, so they are perpendicular lines. So let's look at their slope. CD is 3 over 2, but DA is -2 over 3. So I have 3 over 2 and -2 over 3. If you look at those two numbers, hopefully you notice that this one and this one are the same, except they are flipped over. The second slope is the first one flipped upside down. It's the reciprocal. It is also the opposite sign. So I have taken the slope of CD, I have flipped it over and changed the sign to get the slope of DA. That's because they are opposite reciprocal slopes. That's fancy name for change the sign and flip it over. And I'm going to tell you something in a minute that'll help you remember it. They are opposite reciprocal, and that's because these are perpendicular. This is the symbol for perpendicular. Now let's go back and look at AB and BC. AB and BC are also perpendicular, and if you look at their slopes, I have 3 over 2 and negative 2 over 3. Same relationship. They are reciprocals, they're flipped over, and they have opposite signs. So this is the same thing. It's also opposite reciprocal, and it's because they're perpendicular. So here's what I want you to think about. What can you conclude about the slopes of parallel lines? Well, look at my 2 sets of parallel lines. Their slopes were always identical. Parallel lines have the same slope, and this will always be true no matter what math class you're in, no matter what math problem you're doing. Parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals. Now here's what we're going to do to help us remember this, because in order to do the opposite reciprocal, I'm going to remind you, I had to take the fraction, I had to flip it, and change the sign. So when you have perpendicular lines, what I want you to remember is that you need to flip and change the sign, okay? Just like you're really angry, and I want you to flip and change the sign. So you have to flip it and change the sign. So parallel lines have opposite reciprocal slopes. That's an O, and it's really ugly. And so I want you to remember flip and change the sign. So flip it and then change the sign. So we're going to do some practice. Okay, we have a graph right here. First thing we're going to do is find the slope of this line. So step 1, find 2 pretty points. There is one right here, and there is another one right here. And so to find my slope, I'm just going to count rise over run. So to find my rise over my run, I go up 1 over 2. So the slope of this line is 1/2 because I went up 1 and to the right 2. The slope of a line parallel, well, if you remember, parallel lines have the same slope, so it's also 1/2. The slope of a perpendicular line will flip and change the sign. So I flip it 2 over 1, and instead of being positive 1/2, it's negative because I changed the sign. So the slope of a perpendicular line will be negative 2 over 1. If you want to test to make sure that your perpendicular slopes really are perpendicular slopes, you can take the original slope, which is 1/2, and multiply it by the perpendicular slope, which was negative 2 over 1, and your answer should equal negative 1. If it doesn't, they're not really perpendicular. So 1 times negative 2 is negative 2, 2 times 1 is 2, and that reduces to negative 1, so this checks. If your original slope and your perpendicular slope multiply to negative 1, you're all good. So let's do it from a table. I'm given a table and I am asked to find the slope. So first thing we're going to do is use this table and we're going to find the slope. So it doesn't matter which 2 points you use, I'm going to use this one. So from 12 to negative 8, that is going to be a change of 20, and it's negative 20 because I went from a positive to a negative, so it's getting smaller. And from here to here, from 1 to 6, is going to be a change of positive 5. So the slope of this line is the change in y over the change in x, so it is negative 20 over 5, which simplifies to negative 4, or negative 4 over 1. The slope of a line parallel to this will be exactly the same, so it will be negative 4 over 1. But the slope of a perpendicular line, flip and change the sign. So flip it 1/4 and change the sign. So instead of a negative, I will have a positive. And we can test them by multiplying again. Negative 4 over 1 times 1 over 4 gives me negative 4 over 4, which is negative 1, so it checks. They really are perpendicular. You do not have to do that every time, but if you are unsure, it's a good check. So again, I found my slope with change in y over change in x. Parallel lines are the same. Perpendicular, flip and change the sign. So now I have 2 points. Instead of given a graph or being given a table, I'm given 2 points, and they say, what's the slope of the line? So we're going to use that slope formula we learned. Change in y over change in x. So I have to do y2 minus y1. Well, y2 in this case is 14 minus y1, which is 8. And then x2 is 4 minus x1 is 2. 14 minus 8 is 6. 4 minus 2 is 2. And 6 over 2 is the same thing as 3 over 1. So the slope of my line is 3 over 1. So the slope of a parallel line is 3 over 1. The slope of a perpendicular, flip it, so it's 1/3. Change the sign to its opposite. So instead of positive, I have negative. And you can check them to make sure that they're right, but I promise you they are. So one last thing. This is a fun one. Given this linear equation, y equals 8. First of all, what is the slope of the line? This is where these acronyms that we learned come in handy. HOI and VUX. If you remember HOI, horizontal lines, 0 slope, or y equals. This equation is y equals. There is no x, there is no anything else, it is just y equals. That means this is a horizontal line. And since it is a horizontal line, that means it has 0 slope. So the slope of that line is 0. So the slope of a line parallel to this is 0. Now if you think about a horizontal line, it looks like this. If I want a line perpendicular to that, it has to be vertical, because the only thing that crosses that at a 90-degree angle is a line that goes straight up and down. Well, vertical lines have undefined slope. So you can't flip and change the sign on this one. You need to know this is horizontal, so this one's vertical. So the slope of a perpendicular line is going to be undefined because it will be vertical. So an equation of a line that's perpendicular to the one given, vertical, undefined, x equals. So an equation of a line that's perpendicular, oh, let's go with x equals 8. Any number you pick here is totally fine, because any number that x equals will still be perpendicular to that y equals. But I just chose 8 because that's the one that came to me. So there is parallel and perpendicular slopes. Hopefully you get parallels the same, perpendicular, flip, and change the sign. So remember, you got to flip and change the sign. Okay? I will see you guys tomorrow. Have a good rest of your weekend.